A professional baseball should weigh 5.125 ounces. This is the ideal weight that all baseballs would weigh, with a tolerance of 0.125 of an ounce, or an eighth of an ounce. This is the amount of error that would be okay for the baseball to have, and they could still use it in a game. Write and solve an absolute value inequality. Well, the amount we could be off by for the weight of our baseball is this eighth of an ounce, or 0.125. And that's the most error we could have. So we would like all error to be less than or equal to 0.125. So the weight of any baseball, x, and the ideal weight, 5.125, their difference is the amount of tolerance, or amount of error we could have. It's possible for the weight of the baseball could be heavier. When I break this up, one possibility is x minus 5.125 be less than or equal to 0.125. It's positive 0.125 because the weight can be bigger is higher. The other possibility is that x minus 5.125, the tolerance that we're going to focus on is negative 0.125. This would be baseballs that are lighter than the ideal weight. And since it's lighter, it could be lighter by at most 0.125, or it could be lighter by 0.1 or by 0.05. And all of those numbers are, in terms of a number line, greater. Right? If we were to look at a graph, negative 0.125, the lightest the baseball could be off by, negative 0.1, negative 0.05. Right? Each of these numbers is bigger in terms of numbers. That's why we're using greater than or equal to when we're talking about the lightness the baseball could have. In both cases, I'm going to add 5.125 to both sides. Which means in the one case, x could be less than or equal to 5.25 ounces. And in the other case, x could be greater than or equal to exactly 5 ounces. If I were to graph this solution, since they're both greater than or equal, both equal to, one greater than or equal to, the other less than or equal to, I'll use a closed circle to indicate the equal to part. The baseballs could be greater than or equal to 5 ounces, or less than or equal to 5.25 ounces. The graph will look like this. Every possible value is between here. 5.125, in this case, would be right in the middle. This happens to be called a conjunction, if they were going